College Algebra, Chapter 3, Section 4, the Library of Functions and Piecewise Functions. These are important functions that you should know on sight, so to speak. The first objective, that doesn't look like it's OBJ, but it is OBJ. Graph the library functions with a reference point for us. So, the first one, the constant function. This is some function f of x equals some constant. Now we're going to say b because that's what it will cross the y-intercept, b. So the graph is just a horizontal line through the y-intercept, in this case b. Could be any number you'd like. B is an element of the reals. What is the reference point? Well, I guess that intercept would be the reference point depending upon where it is. Then we have the identity function. That is a function f of x equals x. You put it in x, you get out that same x. It's the identity. It's identical. What does it look like when you graph it? Well, if you put in a 0, you get out a 0. You put in a 1, you get out a 1. For a 2, you get out a 2. -1, you get out -1. It is the diagonal through the first and the third quadrants, the identity. Its reference point, I guess, would be here at 0, which is normally the reference point for all of these. That's point 0, 0, the origin. Next, the squaring function. F of x equals x squared. This one we're used to. It's our favorite parabola. It goes down, hits the origin, comes back up. The reference point is that origin at 0, 0. Y equals x squared. The next one for the next page, the reciprocal function. Well, instead of f of x equals x, it's 1 over x, the reciprocal of x. What does that look like? See if I can get better and better at these axes. Not so squiggly. In the first quadrant, it does something like this. It approaches the x-axis, positive x, and the positive y. It also approaches in the third quadrant the negative y-axis and the negative x-axis. In fact, the axes are what we call asymptotes. But it's these dashed lines that is the reciprocal function. Next, the greatest integer function. Now, our book uses a different notation, but I'll introduce you to both. It's also called the floor. That's why they've got this notation. In other books, older textbooks, they use a double strike square bracket with an x in it. The greatest integer function returns the greatest integer not greater than the given value. It can be equal to, but it's not greater than. So 0 returns 0, 1 returns 1, 2 returns 2. You might see, isn't that the identity? Sort of, just a second. -1 returns -1, -2 returns -2. But not greater, that's the not greater than, it's the equal to part of this. But if I give you a 1/2, you want to return an integer not greater than 1/2. Well, that would be 0. So all of these, up until you get to 1, are zeros. 9/10 returns a 0, because that's the greatest integer, not greater than 9/10. How about 1.5? Well, it will return a 1. So one way of looking at this is it rounds everything to the left. The 1.5 rounds to 1. The 2.5 rounds to 2. That makes these negatives a little bit backwards because the negative 1/2 rounds to negative 1. That is the biggest integer, not bigger than negative 1/2. 0 is greater than negative 1/2. So all of these round left. And this goes on. Of course, this is the stairway to hell. This is the highway to heaven, or highway to hell and stairway to heaven. Anyway, depends upon which group you're trying to listen to. Greatest integer function. How about the cubic? Oh, the reference point still 0, 0 here. Now 0, 0 might be your reference point for this one because it sort of tells you the center of those two axes. The cubic also has a reference point of 0, 0. It starts down, sort of slows down here, and then ends up. So this is the cubic reference point 0, 0. Square root function. Sort of like the squaring function, except the square root, if it's a function, must leave off part of the parabola. This is 0, and the square root of 1 is 1. The square root of 2 is 1.414, and it does something like this. That lower part of a parabola is left off because it's got to be a function. It must pass the vertical line rule. 0, 0 is a reference point. The next screen, cube root of a function. F of x equals the cube root of x. Now, this one looks sort of like the cubing function, except it's on its side. So it starts down and ends up, but in a little different way, where the cube function was faster, skinnier, if you want to call it that. This one's spread out more. But still, 0, 0 is the reference point. And the last one that we're going to look at is the absolute value function. That's f of x equals the absolute value of x. Now that one is interesting also because it looks sort of like the squaring function, which may make sense since absolute value 1 definition is the square root of x squared. Well, it's going to use this down the centers of these, so it's part of that is the identity, but then it bounces off, so to speak, and this is a straight line, doesn't curve there. That's a corner. Its reference point is 0, 0, but that looks like a curve. It's not. Straight line, straight line. The absolute value function. You need to be able to graph these. You're going to have to do probably a matching of some sort. That would be one way to quiz you on this. Objective 2. Once you learn all of those functions, you can put together a piecewise function. A piecewise function is made up of pieces of other functions. So we usually have a multiple definition of sorts. You've got some function, and it's equal to, this is sort of like what the absolute value has done, except, and that's what the absolute value, I guess, says it's the y equals x and the y equals negative x put together. And it tells you over what intervals. Suppose you wanted x squared as one of your piecewise functions, and y equals, say, 2. And say you wanted it to be x squared for x less than or equal to 0, and 2 when x is greater than 0. So that takes care of the whole number line for x's. Less than or equal to 0, you want it to be the parabola. Except when you get to 0, stop. Because we're only using x squared from negative infinity up to 0, inclusive. And then at 2, you want to start again with a constant function, but not include that point, but then everything to the right. So this is a function. It doesn't violate that vertical line rule because that point at 2, 0, 2 is not included, but everything else is, and the vertical line rule fits it. We know this is a many to one because at 2 you do have all these definitions. So a piecewise function is made up of pieces. Let's go back and remind ourselves. If it's the absolute value function, then it's either x or the opposite of x. This is for x greater than or equal to 0, and this is for x less than 0. So it's made up of y equals x, the identity, when x is greater than or equal to 0, and y equals negative x when x is less than 0. And together, this piecewise setup makes the absolute value function. Now we can go through a bunch of these different things and talk about where is this increasing and decreasing, where is it constant, where are the maximums and minimums. Let's go back up to this one we had here. Decreasing, negative infinity to 0. Nowhere is it increasing. Constant from 2 to infinity. Does that make sense? Maximum, no maximums. This goes to infinity. This, since all of these are the same value, you could think of all those as maximum, but it's not really. We usually look at 1 point or 2 points or something. But this is a minimum here, a local minimum, or in fact an absolute minimum, because the whole function, that's the lowest point. So at 0 you have a minimum of 0. Is this an odd or even? Well, it doesn't have any symmetry with respect to the x-axis or the origin, so it's neither. What about the absolute value? It's decreasing when x is less than 0. It's increasing when x is greater than 0. It has a minimum point at 0. In fact, it's the absolute minimum. It is an even function because it has symmetry with respect to the y-axis. See, we can apply all that stuff. And that's what you'll be doing with the problems. So let's move to page 249. We've already done some of the first ones. You're going to get to do the matching, 9 through 16, on a quiz, so make sure you can match those. I think that's part of your assignment too, anyway. But let's move to number 36, since we've already done some of that, for the 17 through 28. Number 36 is the function f of x. Now that I've moved that down, of course, I keep forgetting to take care of this. I don't know what this looks like on the recording. Let's see if I can do this now without messing it up. Okay. This is the function f of x. Now, it's two pieces. 1 over x. And the cube root of x. It's 1 over x if x is less than 0. Couldn't have it equal to because x couldn't be 0 here. So this is cube root of x if x is greater than or equal to 0. So let's graph this thing. Getting a little better at drawing these lines straighter. Just takes practice. Okay, if x is less than 0, it's 1 over x. So it's the left side of that reciprocal, which is the graph that does something like this. And it approaches the negative x-axis from below and the negative y-axis from the left, greater than or equal to 0. So the cube root of 0 is 0. And if you remember, it started down and ended up, so it's going to look something like this to the right. That's why you learn all those common functions, the library of functions, so that you can do quick graphs like this. So, what do the questions ask? What is the domain? Let's see, the domain is, it goes from negative infinity up to 0. Well, it includes 0 too. This includes everything up to, but not including 0. So it is all the real numbers. In interval notation, negative infinity to infinity. If I ask you for set builder notation, set of all x such that x is an element of the reals, make sure you understand how to do those notations. They ask you, based on the graph, to finally find the range. I'm going to put that right away here. So what is the range? Well, it goes from a negative infinity, because this thing goes all the way down. It gets, this goes and approaches the 0, the x-axis, and then it takes over here. And this thing, although it doesn't look like it, it keeps going higher and higher. So this is all the real numbers from a negative infinity to infinity. The bad thing with the interval notation is it doesn't show you what variable you're talking about. For the domain, it is the x. For the range, it's the set of all y, such that y is an element of the reals. So that's one nice thing about set builder notation. It reminds you of what variable you're talking about and what axes you're talking about. So we've graphed the function. That's part B. Locate any intercepts. So the x-intercepts, where does it cross the x-axis? At 0. I guess it doesn't cross it, but at least it hits it. There's no other x-intercept. What about the y-intercept? Where does it hit the y-axis? At 0. There's number 36. Graph it, find the domain and range, find the x and y intercepts. Pretty fun stuff. So, the next one, number 44. This gives you a graph and then asks you to write the piecewise function. On this graph, it goes from a negative 1 up to 2 on the y, and it's just that segment. Then it goes from the origin, but it doesn't include it, and goes to 2, 2. And it crosses through that and keeps on going. So 1, 1, 2, 2, which of course is a cute little skirt. My granddaughter practiced in. This is 0, 2. They give you all this in the picture. Negative 1, 0. Okay. So, how would you write a piecewise function? Well, notice that right now you got at least one step. That may even be counted as 2. So the function f of x is going to be 2 pieces. This is going to be part of a line. In fact, both of these are part of a line. This one's a little bit special. So let's do the special one first. This is part of not just any line, but this is part of the identity function, which is f of x equals x. All we have to do is tell what part. So let's do that one first. F of x equals x if. Now x has got to be greater than but not equal to 0. So that takes care of the right piece. This one's a line, and we know where that goes. We can say if x goes from a -1 to 0. So a -1 is less than or equal to x is less than or equal to 0. This interval right here. The rest of that, they don't tell us anything. We're out to assume that that's not part of the domain because it's not got any definition there. But from a -1 to infinity, we've got some definitions, 2 pieces. So we got to figure out the equation of a line here. What is the slope? Well, it's 2 minus 0 over, it's 2 minus 0, 1 minus, I'm sorry, 0 minus a -1, which is 2 over 1, which is 2. Slope is 2. And we're given this 0, 2, which is the y-intercept. So b equals 2. So it's the equation y equals mx plus b, or 2x plus 2. That's the function. 2x plus 2 if x is between and including -1 to 1, or -1 to 0. So this is our answer. If you need to box it in. See how much fun this is going to be? I tell you what. Let's do one last problem, which we'll use our calculator with. It's on page 251. We're going to do number 58, and that uses the piecewise function found in number 57. They didn't put it there, but this is really a function in 2 variables, t and v. Well, t is going to be the outside temperature, the temperature without the wind. And so for number 58, they're going to say, and of course I moved it again, gotta be careful of that kind of stuff. They're going to say, let's let T equal a -10 degrees Celsius. And so all of these T's will be a -10. So this T will be a -10, so it'll be +10 right here, right? And this T will be +10, right? With those changes, that'll work for number 58. And we can then put this in our calculator. In y1, you'll have to put it in as -10 in parentheses. And then for this part, you want x. We're going to use x instead of the v. X is greater than or equal to 0. And x is less than 1.97. So you're going to put that stuff in for y1. For y2, I'm not going to write all of this down, but you're going to put in this, make sure it's 33 minus, and then you've got to start your entire fraction here, your this quotient, but then you've got to put in the numerator, and then the numerator has 2 of these parentheses, right? Then you close the numerator, then you can divide. So 1, 2, 3. Okay, and then after you put in the number here, the 22.04, you close the entire thing. So you sort of open the entire quotient there. Start your numerator, give your 2 parentheses expressions, close the numerator, then you do your division the denominator and close the entire thing. Now these outer ones may not be necessary, but if you're not sure, that's what you need. And then for this, remember to work with this. So this might be an extra pair inside here, but it's better to put the extra pair than not, I think. Now you've got this, you can do the 1.79 is less than or equal to x, and the x is less than or equal to 20. That will go in y2. In y3, we're going to put, start your parentheses, 33 minus the 1.5958. And here we can put in the 33 plus 10, or 43, and close that for this expression, and then do the x greater than 20. So, pause this video right now, and put these things in, and then we'll come back. So I hope you got it all in. This is what my screen looks like. It's really a lot of parentheses in there. Yours with the new operating system might be an awful lot nicer than that. But the key here is, and I've gone to my dot mode so that you can see it a little better without the vertical lines in there. Your graph should look like this when you graph it. Oh, and how do you get that? Set your window, say 0 to 30. And I've made the scale 5, so it'll count by 5. And then do a zoom fit. And when that fits it to the screen, then your graph should look like, after it calculates all this lower, the y-min and the y-max, should look something like this. Mine's the dot mode, so some of those points are spread out, but it should be pretty good this time. That's what it should look like. I think because we got 0 here because of the 0, and that's good, so that we can see the axes here. If you didn't get that, you got to look back at all the parentheses that you might or might not have. Maybe this should show everything except for that last one completely. That middle one, y2, is the one that's usually the problem. But you need to put parentheses around all this stuff the right way. So you can pause now and see if you've got a problem with that graph, what you might have done differently than I have. Then when you come back, you can pause it again, and I'll look at the one y3. So if you're back, this is y3. And it has the function. I used 43 instead of that 33 plus 10. And x greater than 20. Okay. Remember, you get for those less thans, greater thans, less than or equal to, greater than or equal to. It's second math to get to the test menu. Now that you've got the graph, we'll assume, they have a bunch of questions. So, part A, one of the more fun parts. The air temperature, ours is -10, wind speed at 1 meter per second. Compute the wind chill. So, if we're supposed to give it the V, we've taken care of the T, that's the -10. So we're just going to give it the V. So get out of this thing, second quit, grab your Y. Which one are you in? If the velocity is 1 meter per second, then we're in this first part of the definition. So we have to use y1. So we're going to take and find vars, y-vars, function y1 of 1. Because this part takes care of everything up to 1. Oh, it should be 1.79. Oh my gosh. 1.79 here instead of 1.97. Yep, I switched those two. Maybe I'm dyslexic. I don't know. Maybe I'm just getting old. Y1 of 1 is negative 10. Well, that makes sense. We may not even have to do that, right? Because no matter what, I guess, velocity between 1 and 1.79, it's going to be a minus 10 degrees if it's minus 10 degrees out. Okay. Part B. Air temperature negative 10 for us and wind speed of 5. So until we get to 20, we're going to use this y2. So you go grab that vars, y vars, function y2 of, in this case, 5. So if it's 5 meters per second, right? Meters per, what is it? Meters per second. Then it would feel, even though it's just negative 10 Celsius out, it would feel like a negative 21.25. Part C, air temperature, in our case negative 10, wind speed of 15. So now you can bring this back, do a second enter. You don't have to go and grab that y2 again. And replace the 5 with a 15 and press enter. So all of a sudden now you're down to negative 33. It's negative 10 Celsius out, but it's a negative 33 and 2/3, I guess. What about 25? Well, now we use the third part because that starts when you get to 20. Well, I guess 20 is the second part, y2. Greater than 20 is the third part, and 25 certainly is. So we're going to grab y3, vars, y vars, function y3 of 25. So it's like f of x here, or in our case w. A negative 35.61. Part E, which is another really fun. Part D is fun. Part A, Part D, Part E. All really fun parts. Part E, explain the physical meaning of the equation corresponding to the 0, well, that's this one here, the first one, 0 to 1.79. Well, that means it doesn't matter, the wind doesn't play any part in how this feels on your skin. The wind chill factor doesn't come into effect until you get faster than 1.79 or like 1.8 meters per second. So that's part E. Part F, explain the physical meaning of the equation corresponding to greater than 20. That's this third one. Once it gets greater than 20, then the velocity, again, plays no part. It's always the 1.5958. Instead of all this extra stuff divided by 22.04, you just have this 1.5958 times the 43. That's depending upon the outside temperature. 33 plus or minus, I guess it'd be minus the outside temperature. So the x part is only for this y2. The x in our case was the velocity of the wind. Once it gets over 20, it's just going to be cold. Now this is Celsius. What does a negative 35 Celsius really mean? Remember, 0 Celsius is freezing 32. So this can be pretty cold. Negative 35 Celsius. My gosh. Okay. That's for another problem. This is problem 58. Interesting problem. Don't really get it here in Louisiana. But if you're going to go to college up north, you might want this formula to figure out how cold it is outside. See you next time.